Welcome to The Explainer. Today, we're going to fundamentally shift how you think about AI adoption. Think about the AI tools you use every single day. For a long time now, there's been this really prevailing assumption that getting people to use and truly trust artificial intelligence relies purely on building smarter, faster, or mathematically more accurate algorithms. But as we're about to see, trust isn't just some engineering byproduct. It is a deliberate, psychological UX design choice. We're going to dive into the data and the core design principles that prove why the way an AI presents itself to you is honestly just as critical as what it actually computes behind the scenes.
Let's kick things off by challenging a pretty massive myth in the tech world. There's this common belief that a truly powerful AI model doesn't actually need a user interface, that the ultimate design is simply a clean, minimalist, blank text box. The logic goes kind of like this. If the AI is smart enough, you just talk to it, it understands you perfectly, and all those old-fashioned buttons, menus, and toggles just fade away. But assuming the AI simply knows what you mean is an incredibly risky strategy, and it totally ignores decades of human-computer interaction research. In fact, to understand why this blank box is so dangerous, we have to look at a psychological trap we've literally been falling into for over 50 years.
To understand that trap, we've got to travel all the way back to 1966 in a program called ELIZA. ELIZA was a very simple natural language processing tool, but researchers found that people started confiding their deepest, most personal secrets to it. This birthed what we call the ELIZA effect. It's our natural human impulse to assume that any system generating human-like language actually possesses human qualities, things like intelligence, empathy, and genuine care. We all do it. It's practically hardwired into our brains. By giving users a completely open-ended chat interface today, we are leaning right into this effect. It makes simplistic interfaces deceptively dangerous because they strongly encourage us to blindly project competence onto what is, essentially, just a statistical engine.
There is a massive gap between what we think is happening and the reality. We have the polite fiction of a fresh conversation, the simple, straightforward question you type in, contrasted with the massive reality of the hidden context window. Before your words even reach the model, the system has already rapidly assembled your past conversation history, deeply hidden system prompts, environmental signals, and user preferences. Most interfaces give absolutely no indication that this complex assembly is occurring right under your nose. This invisible process can produce baffling, totally unexpected results that end up completely eroding your trust when the machine seemingly misinterprets a super simple request.
Section 1. Anxiety in the black box.
To see exactly how this invisible complexity impacts real people, we can look at the high-stakes world of healthcare. This introduces a really vital concept. Algorithmic accuracy alone is absolutely not enough to secure human trust when the stakes are high. Data from a recent UAE healthcare study reveals something fascinating about how medical professionals adopt AI. What the data clearly shows is that explainable AI drives adoption not by making the clinical users smarter or more technically proficient, but primarily by reducing their anxiety. Transparency significantly lowers the emotional barrier to entry.
This brings us to a crucial takeaway. Transparency reduces user anxiety more effectively than pure accuracy. In the context of healthcare professionals adopting AI for diagnostics or treatment, feeling psychologically secure actually mattered way more than simply believing the system was cognitively reliable. Really think about that for a second. Emotional discomfort can completely override cognitive reassurance. If an interface doesn't actively work to lower that underlying anxiety, the user is going to reject the tool entirely, no matter how mathematically flawless the underlying math happens to be. Section 2. Outputs are starting points. We really need to completely rethink how we consume AI outputs, especially given our human need for psychological comfort. Often, AI interfaces will display a metric like 93% confidence. We see this and intuitively think it works like a spell checker's accuracy rating or a definitive grade on a test. But this is a very dangerous illusion of false precision. That number doesn't represent factual, real-world truth. It simply represents the mathematical probability of the next word. It's like a superpowered predictive text engine, not a verified factual truth. Presenting this as a percentage manufactures an unearned sense of trust rather than providing true, actionable transparency.
And that leads us to a pretty terrifying reality of modern generative models. The absolute most dangerous errors arrive wrapped in perfect grammar, formatted beautifully, and delivered with absolute algorithmic confidence. Because the model fundamentally doesn't know when it is actually wrong in the real world, it cannot warn you to be cautious. This shifts the heavy burden of error detection entirely off the machine and squarely onto your shoulders.
This is exactly why design experts argue unequivocally that the output is not the answer.
We have to fundamentally treat AI outputs merely as starting points that require active human verification. This is especially true when you're dealing with actionable or objective tasks, like summarizing a complex legal policy, auditing financials, or making a medical recommendation. The interface itself needs to be carefully designed to facilitate your verification rather than just encouraging you to blindly and passively accept whatever it spits out.
Research analyzing over 60 different studies shows something wild. Human AI teams can actually sometimes perform worse than humans working entirely alone, and it's specifically due to over-reliance. To mitigate this, designers have to introduce strategic friction. We need cognitive forcing functions. Basically, these are deliberate digital speed bumps that interrupt your automatic acceptance of an answer and literally force you to think. We also need progressive disclosure, which means revealing complex information slowly, step by step, rather than just dumping it all at once to build realistic mental models. The goal here isn't to make the system as frictionless as possible, it's to foster appropriate reliance so you remain an active, engaged collaborator.
Section 3. Designing for agentic AI.
Welcome to the Wild West of our technological future, agentic AI. We are rapidly shifting from systems that just chat with us to systems that interpret goals, make plans, and take autonomous action on our behalf. Because these systems operate autonomously, agentic workflows demand a new, absolutely crucial design rule, and that is revealing the plan. The process has to follow a clear sequence. First, the user states their intent. Second, before anything else happens, the AI proposes a structured plan. Third, the human verifies it. And only then, fourth, does the AI execute. You absolutely have to agree on the scope of work before any hidden computation begins.
When an autonomous agent dives straight into a black box execution, correcting a misunderstood prompt later on is expensive and incredibly frustrating for you. You've wasted time, you've wasted compute power. But by exposing the plan first, you transform the interaction from a blind delegation into a shared contract. You are establishing exactly what is expected, step by step. Trust here isn't just built on good final results. It is built on predictable, observable behavior and tightly aligned expectations right from the very start.
You can see this shared contract in practice with interfaces like Claude. By offering simple clarification toggles, like quickly tabbing through specific targeted options before a complex task begins, the system actively reassures you. It shows it actually understands the delicate nuances of your request and is going to spend its computational effort wisely. It reinforces a profound sense of shared authorship rather than making you feel like you're just tossing a coin into a wishing well and hoping for the best. To make this autonomous operation safer, modern agents use something called reflection. This is a super cool mechanism where an agent critiques its own output, running a deliberate second pass to check its logic, test code, or verify facts before it ever shows it to a human. For designers, the tricky part is a balancing act. When do you silently fix these errors in the background so you don't bother the user? And when do you visibly show the agent checking its work to actively build trust?
As we look forward, these are the new defining principles for agentic UI. We must reveal the plan. We must prioritize what matters most. Agents generate a massive amount of intermediate data, internal status messages, tool calls, background code checking, API pings, and if an interface shows all of that, you are going to be entirely overwhelmed. We have to perfectly balance that transparency with cognitive load, meticulously designing for shared control to ensure human judgment always remains the ultimate authority.
I'll leave you with this final thought. Confidence is a collective performance, something that must be earned, not assumed. As you design or interact with the next generation of AI, ask yourself, are you merely buying into an illusion of intelligence wrapped in a sleek chat box? Or are you demanding the necessary, sometimes friction-filled hard work of earning genuine psychological trust? Think about that the next time a machine claims to be 93% confident.